Hi, my name is Lincoln Dale and I'm here to talk to you today about Arista's cloud scale network designs. So Arista as a networking company has been built around switches in the data center, and to that end we've been very instrumental in enabling our customers to scale from what has historically required 3 tiers of networking equipment down to 2 tiers, what we call spine leaf designs. A key part of what we've done at Arista is some of the scale that can be achieved on some of our switches. A great example of this is the Arista 7500E series, which enables up to 1152 10 gig ports, 288 40 gig ports, or 9600 gig ports, all in a very compact 11U chassis. With the introduction of the Arista 7300 series, we support up to 2048 10 gig ports. This also introduces the concept of flexible airflow, either front to rear or rear to front, to a modular switch. Is really all about enabling optimal placement of these switches in data center server racks. Just as Arista did with 1U top of rack switches, where ports could be placed in either the hot aisle or the cold aisle of a server rack, we can now do this for a modular switch, which enables a true modular end of row or middle of row type collapse designs. The Arista 7304 with 4 line card slots scales up to 512 10 gig ports. The 7308 8 slot chassis scales up to 1024 10 gig ports, and the 7316 16 slot chassis scales up to 2048 10 gig ports. This same chassis also supports 10G-base-T that enables deployment for gigabit copper RJ45 links, and in fact even works at 100 megabit, gigabit or 10 gigabit, enabling seamless migration for legacy servers to faster links now or in the future. Incredibly, this represents 10 gig being done at a lower power envelope than historically what many legacy switches have been capable of doing gigabit at. For most enterprises, what this represents is that an entire data center can now be connected using a single tier of switches, and the networking layer literally just collapsed into a pair of switches. The term we use for this at Arista is what we call a spline design, or a collapsed leaf spine. Some of the key points around our designs include, firstly, no proprietary lock-ins. Nothing we do at Arista is a lock-in to using Arista. You're actually free to connect us to any other vendor's equipment now or in the future. Our designs are built around fewer tiers being better than more tiers. If your data center network requirements can be met by a pair of switches, it's a great design. There's no point wasting ports for connecting different tiers of switches together. This also offers not only the best price point, it also offers the lowest oversubscription, as essentially there is no oversubscription going from any port to any other port. All of our designs also have no protocol religion. If you want to build a network at layer 2, that's fine. If you want to build a network at layer 3, that's fine. If you want to build a network using overlays in software, that's fine too. If you want to build a design making use of the hardware VXLAN gateway capabilities on our switch that enables layer 2 over layer 3 in a seamless manner, that's fine too. We really don't have any religion over what's right or wrong. It's simply a case of some designs are more optimal, but we give you the flexibility. Modern data centers should also be active-active. We have protocols like MLAG that allow active-active connectivity to servers and storage and between switches. Key point here is, why do you want to buy ports on switches that are blocked waiting for a failure? You might as well take advantage of the performance that is available running everything active-active, and you only have a service disruption in the unlikely event that you have a disruption somewhere. Design should also be agile and provide flexibility around port speeds. Arista leads the industry with flexibility of a single MXP port, a multi-speed 100 gigabit port that can either operate as 1 by 100 gig, 3 by 40 gig, or 12 by 10 gig. Historically, jumping between speeds has required a forklift upgrade or new line cards, new chassis, things of that nature. What we have here on some of our switches is the ability to buy a 100 gig port, use it as 12 by 10 gig today, use it as 40 gig in future, and 100 gig further out, all within the same CapEx profile. Our designs also scale out over time. If you are building a multi-tier network, you could start with a pair of switches at the spine, minimal number of line cards. As the design evolves over time, you can add more line cards in the spine, or in fact you can even grow the number of spine switches from 2 switches to 4 switches to 8 switches. And Our designs are flexible and we have the investment protection that enables this. Buffers on switches also matter. Many modern workloads and operating systems make use of techniques that can push a lot of data onto the traffic in a very short time space. Deep buffers are used to absorb those bursts without drops in the network. We have a single software image on our switches that is consistent across all switch platforms. We have one operating system, EOS, and it's the same binary image that's deployed across all of our platforms. What this means is you can deploy our software and know that it just works everywhere. There's no retraining, there's no inconsistency between features or functionality. Lastly, we have interoperability. Nothing we do prevents interoperability with other vendors. In fact, the automated testing that we have here at Arista ensures that we can be deployed alongside other vendors with no real concerns. This is a brief summary of many of the key design tenets we have around modern scale-out cloud network designs. Thank you for watching. For more information, please visit our website.